Hi guys, welcome back to another video. This time it will be on one-dimension kinematics. So I'll just be using the equations of motion, the standard ones, to solve this problem. So we have a jet touching down at 300 kilometers per hour. It then decelerates at 4.5 meters per second squared. And we have to find the minimum length of runway of which the jet can land. So when approaching this type of problem, we have to find out what variables we have and what variables we're looking at. So we have 300 kilometers per hour. That's going to be the initial velocity. It says it decelerates at 4.5 meters per second squared. So that's our acceleration. And we're looking for the minimum length of runway. So that's going to be our x value. So this is the variable we're looking for. We have the initial, and of course it's landing horizontally, it's one dimension, so it's all going to be x values. The initial velocity is 300 kilometers per hour, but we want that in meters and per second. So all we do is write 300 times 10 to the power of 3. We divide it by 60 once to get it in minutes, and by 60 again to get it in seconds. And this gives us a value of 83.3 meters per second. We also have the final velocity, because of course we're looking for the time when the plane can stop, so obviously the velocity will be 0. And then that means we also have the initial displacement, which is also 0. And it decelerates at 4.5 meters per second squared. Because it's decelerating, the value will be negative. And I think this is all that's needed. So now we need to find a suitable equation of motion. So let's use v squared equals initial velocity squared plus 2 times the acceleration multiplied by the final displacement minus the initial displacement. Now we are looking for this value. So if we rearrange this, we get x equals v squared minus initial velocity squared over 2 multiplied by the acceleration plus the initial displacement. And now all we have to do is plug the numbers in. So we get 0 minus 83.3 squared over 2 multiplied by minus 4.5 plus 0, and this gives us x. And let's plug this in. This gives us an answer of 771 meters. And that's all there is to this sort of problem. We're only looking in one dimension, so it's very easy. Just find the variables which are in the question and find the variable what you're looking for, and then all it is plugging the number into the right equation of motion. So in the next video I'll be doing some 2D and 3D problems.